Before sunrise, a black bag hits the curb. Inside are coffee grounds, packaging, broken plastic, and yesterday's leftovers. By lunch, it may be gone so completely that the street looks as if nothing happened. But that disappearance is not magic. If one truck fills too early, if one transfer station backs up, if one sorting line rejects a contaminated load, waste begins returning to the place cities fear most: public space. The paradox is simple. A city stays clean only by moving its dirtiest material through a carefully timed sequence of limits. Hiddenova follows one ordinary trash bag at dawn. The story begins at the curb, but the real drama is not the pickup. It is the pressure that starts the moment a collection truck turns onto a route already shaped by distance, traffic, fuel, labor, and capacity. Every stop adds weight. Every misstop creates complaints, odors, and safety risks. The city's waste system has to make thousands of small decisions feel like one smooth disappearance. To understand how millions of tons are removed, we follow the bag through the places most residents never see: the truck body, the transfer floor, the sorting line, and finally, the land where disposal becomes permanent. The journey begins long before the truck arrives. Collection routes are not random loops through neighborhoods. They are planned around where bins are placed, how quickly crews can reach them, how roads handle large vehicles, and where the truck must go once it is full. A missed turn can waste time. A narrow street can slow an entire crew. Parked cars, construction, weather, and rush hour traffic all turn a simple pickup into a moving calculation. This first stage determines whether the rest of the system receives waste in a steady flow or in sudden bursts. The truck crew is doing more than lifting bins. They are converting scattered piles of household waste into one controlled stream. When the truck stops at the curb, the bag is no longer an isolated object. It becomes part of a load that has to fit within a route, a schedule, and a vehicle that cannot expand just because the neighborhood produced more trash than expected. That limit leads directly to the next pressure point: the truck itself. A garbage truck is not just a container on wheels. It is a machine built to delay the moment it must leave the route. As waste enters the rear or side of the vehicle, a compaction system presses loose material into a denser mass. Compaction matters because uncompacted waste is mostly awkward shapes and trapped air. By squeezing it, the truck can collect from more stops before driving away to unload. That changes the economics and rhythm of the day. Fewer early trips mean crews spend more time collecting and less time traveling empty roads between the route and the next facility. But compaction has limits. Heavy materials, bulky items, and wet waste can fill weight capacity before the truck appears physically full. If the truck reaches its limit too soon, the route pauses. The crew must leave the neighborhood, unload, and return if the schedule allows. On a busy day, that delay can ripple outward. The first disappearance from the curb depends on a steel chamber winning a constant fight against volume and weight. Once a collection truck is full, sending it all the way to a distant landfill would waste valuable collection time. This is why many cities rely on transfer stations. A transfer station is an intermediate facility where local trucks unload waste so larger vehicles can carry it farther, in bulk. The logic is practical. Small trucks are good at navigating streets. Large trailers, rail containers, or other bulk transport systems are better for longer distances. At the transfer station, the bag may land on a tipping floor, a broad concrete area where loads are dropped, inspected, pushed, and consolidated. This is where the city's flow becomes visible. Trucks arrive in sequence, doors open, and waste that was spread across blocks appears as a rising mass. If the floor becomes crowded, incoming trucks wait. If trucks wait, routes lose time. If routes lose time, collection can fall behind. The transfer station acts like a valve. It does not solve the waste problem, but it prevents every local truck from being trapped in long disposal journeys. Not everything collected should be buried. Some material enters recycling systems where the goal is to recover paper, cardboard, metals, glass, and certain plastics. But recycling only works when the incoming stream can be sorted into usable categories. At a materials recovery facility, mixed recyclables move across conveyors, screens, magnets, air systems, optical sorters, and human quality control stations. Each stage separates material by shape, weight, magnetism, or appearance. The process looks mechanical, but it is vulnerable to contamination. Contamination means unwanted material mixed into the recycling stream: food residue, plastic bags, broken objects, liquids, or trash placed in the wrong bin. These items can slow equipment, reduce the quality of recovered material, or cause portions of a load to be rejected. That consequence is important. A recycling bin is not a guarantee of recycling. It is an application to be sorted. If the material cannot be separated cleanly enough, it may lose its value and be diverted toward disposal. The cleaner the input, the more useful the output becomes. Material that cannot be recovered moves toward final disposal, often at a landfill. A modern landfill is not simply an open pit where waste is thrown and forgotten. It is an engineered site designed to place waste in controlled cells, compact it, cover it, and manage the byproducts that come from buried material over time. The exact design varies by location, but the purpose is consistent: contain waste and reduce uncontrolled contact with surrounding land, water, and air. When trucks arrive, they are directed to an active working area. Loads are tipped, spread, compacted, and covered according to site operations. This is where the scale of consumption becomes difficult to ignore. The bag that vanished from the curb now joins countless other loads in a landscape shaped by capacity. Landfills require space, management, monitoring, and long-term planning. When disposal space becomes harder to secure or farther away, transportation costs rise and cities feel the pressure upstream. The final destination changes decisions made back at the curb. The waste system usually succeeds when residents do not think about it. But its weaknesses appear quickly when one part slows down. If collection is delayed, bags sit outside longer, attracting pests and creating odor. If trucks spend too much time unloading, routes can stretch beyond the planned day. If transfer stations back up, collection vehicles lose their role as neighborhood machines and become waiting vehicles in a queue. If recycling streams are heavily contaminated, more material may be rejected, reducing the benefit of separation. If disposal sites are distant or limited, the cost of every ton becomes more sensitive to fuel, labor, and time. These consequences show why waste management is not one service, but a sequence of dependencies. The curb, truck, transfer station, sorting facility, and landfill all affect each other. A city does not remove waste by one grand act. It removes it by preventing small bottlenecks from becoming public failures. That is why the most ordinary bag on the sidewalk carries a map of the entire urban system. By the time the street is clear, the waste has not vanished. It has been transformed from a household problem into a logistical, mechanical, and environmental responsibility. The cleaner sidewalk is only the visible result of route planning, compaction, transfer capacity, sorting discipline, and engineered disposal. This system reveals an uncomfortable truth about cities. Cleanliness is not the absence of waste, but the ability to move, separate, and contain it before it overwhelms shared space. Every bag placed at the curb enters that bargain. The city can remove it, but it cannot make it stop existing. If you want more documentaries about the systems cities depend on, comment with the infrastructure you want explored next. Like this video, and subscribe to Hiddenova.